how are we doing? What am I looking at today? Today I'm going to have a second look at the LM317. I've done a previous video on this, so go watch that if you haven't yet seen it. But this time I'm going to have a little bit more in-depth look. I'm going to quickly go over the mass that is involved, and it's very simple really, because it's a very simple device, which is why I like it so much. So, and then I might have a quick look at one of the circuits that are on the data sheet. So let's get and have a look at that. Okay, so here we've got some information, some diagrams I've drawn on the rich CAD, or the poor CAD, whichever one you want to use, on the circuit. So I have covered this briefly before. The LM317 3-pin item, input, output, adjust. If you want to get an output of a particular voltage, you have a resistor divider. This wants to create a reference voltage of 1.25 volts across this resistor, so this one will determine what you get out here. Very simple, but of course if you want it to vary, you don't want just one resistor, a single fixed resistor there, you want a pot. And that is actually how it sort of sits in circuit. That's your resistor, that's your pot. I've got here 260 ohm in R1, and this second one is 4K7, 4700 ohm resistor that I can move up and down, give me an output depending upon my input. So anything from sort of 5 volts all the way up to 30 volts or something gives me an output minus the voltage drop, or the reference voltage. Very simple. Very simple maths as well. To do that, the voltage out is the voltage reference, which is that 1.25 volts, times by 1 plus R2 divided by R1, plus this current adjustment on R2. Now, just to have a quick look at that, on the adjust, there's a tiny amount of current there, and it's a very small current that's, well, it tries to regulate it at a particular current, so that's how, one of the ways that it obviously creates this reference of 1.25 volts at that point. But it's so small that unless we're doing some special circuitry, then that is really not relevant. I don't need to know about that. So basically a V out is 1.25 volts times by 1 plus R2 divided by R1. That can't be any simpler than that. That is so simple. It's just a very, very simple equation to work out what you're going to get from this. So I've done a bit of calculating, depending upon the values of the materials I'm using, the components, sorry. So R1, 260 ohm. R2, my pot, is 4K7. So 1.25 plus 1 plus 4K7 over 260, 1 plus 1807, which means I get 1.25 times 19.07, which gives me a possible output of up to 23.83 volts. Obviously that's dependent upon what my supply voltage is. So if I could put in, say, 3 volts up to 25 volts, then I can get out of it somewhere between 1.25 volts, which is the reference voltage, all the way up to 28.83 volts, which is the total voltage I managed to get out of it. But what if I use a smaller pot to as my R2 instead of that big 4K7? I use a 1K pot. So 260 ohm, 1K, same equation, 1.25, 1 plus R2 over R1, so I've got 1000 divided by 260 gives me 1 plus 3, so 1.25 times by 4.846 will give me a maximum voltage of 6 volts, or around about 6 volts. Obviously your percentage variance on your components, I mean, pots usually have anything between sort of 10 to 20% tolerance, so I mean it could be way off from the 6 volts, but supposedly up to 6 volts. So if I had a supply voltage of between, say, 3 to 25 volts, I would only get out of it 1.25 up to 6 volts around about. It wouldn't go above that because that 1K will restrict how high it'll go. Whereas with the previous one, the 4K7, I can actually get myself all the way up to nearly 24 volts, depending upon my input, my supply voltage. So the other thing I've done as well, had a quick look at, is current limiting. You can limit the amount of current with an LM317 by putting a resistor in series. So effectively the reference point, the 1.25, is now across this series resistor. So the equation to work out the current that you're going to get is current equals voltage reference divided by R1, depending on what you put in there. Very simple. Voltage reference again, 1.25 volts. The current that I might want out, 300 milliamps. So 1.25 over 3 milliamps equals 4 ohms. So there we go, that's R1. Again, this is a very simple equation. Just rearrange R1 voltage reference over current. 4 ohms. Very simple. I haven't got 4 ohm resistor though. Also, watch out for the wattage, because this thing will get hot. Obviously, if you're drawing 300 milliamps, or let's say you're going to want to draw something much bigger than that, you want to draw, let's say, nearly an amp, as the 317 can supply up to nearly an amp in current, then you're going to need quite a hefty resistor, otherwise it will burn out quite quickly, depending on what you're drawing off from it in the circuit. So I haven't got a 4 ohm resistor. What I've got is 3 10 ohm resistors. So I've just put them in parallel to give me around about 3.3 ohms. So this is one of the circuits I'll be doing. What I'll do is I'll start off with a basic circuit with just the these 2 resistors and see what I get on the output, and then I will put in, I'll actually change this. I'll start off with a 4K7 and then I'll put in a 1K so you can see the change in how much it can go up to, and then I'll look at the circuit with this resistor in it to limit the current. Right, so let's get on with that. Okay, so here we go. I've got this on the test bench. This is my LM317 that I'm using first. I've got 2 set up on here. Save me messing around too much. Ignore that bit, something else. Yeah, let's not mention that bit. Couple of multimeters. This one is for the voltage on the output, and this is the current for the device I'm going to power. It happens to be an LED. This LED, I believe, is a 1 watt 3.3 volt LED that supposedly draws about 300 milliamps. So I think that's the sort of rating of it. I wasn't quite sure. I couldn't find the data sheet originally, but I think I found some details, and I think that's the LED that I've got sitting in here. I have put a resistor in series with it, but we'll test it out afterwards without that resistor in series. So let's have a look at this. First of all, I've got 5 volts on my power supply, so let's turn this on. 1.25 volts, 1.26 with 5 volts. So that's as low as it'll go. So let's turn this up, and I happen to know from previous testing it's about 2.5 volts before this LED comes on. So that's now come on, and as I turn this up, I've got about 30 milliamps, 3.36, and that's about as high as it goes. I can keep turning the pot up and nothing happens because I've only got 5 volts on my supply. Let's put that on there. I've only got 5 volts on my supply, so there's a drop of about 1.5 volts, supposedly the reference voltage, so it's a bit more than that on here. But yeah, you can see there's a dropout because it can't deliver any more than that because the supply voltage is only at 5 volts. So let's whack this up to 9 volts. I mean, that would be a more sensible one. And as you see, I didn't turn it off. Could have done, switched it off. But even when I did that, as I turned it up to 9 volts, that didn't change because it's regulating at its lowest point. So if I start turning that up, I get LED comes on about 2.5 volts, and the voltage goes up higher than that. And you see my current's going up, getting up there. 6 volts, 7 volts, and that's about it. Because again, we've got a certain amount of dropout. We've got 9 volts on the power supply. I'm getting 7.23 on the output of this LM317, and I'm drawing 260 milliamps. Great, that's brilliant. It's not far off what this is probably requiring, because this resistor is obviously dropping some of that voltage. Hey presto, that's brilliant. I like that. But let's turn this power supply up to 14 volts, which is about as high as it'll go. As you can see, as I've turned it up, that stayed the same, didn't change, because the regulator's regulating at its lowest point. Brilliant. So I'll start turning this up. LED comes on, and we start drawing more current. I should be able to go a much higher voltage. The only trouble is I have to be careful, because this LED should only be drawing as a maximum just over 300 milliamps. Now I'm at 300 milliamps already, but I'm at 7.85 volts. Now supposedly, as you can see, I can go above that and take it up somewhat rather more, but then I will be overdoing it on the current and likely to destroy my LED. So let's turn that down. And what I'm going to do now actually is I'm going to connect this LED directly without the series resistor. So let's just turn that off. Turn this down to 5 volts again, start there, and connect on this side. So I don't have this series resistor anymore. This output's going directly through my LED. Could be frying tonight. .26. Turn that on, and what do we get? It starts drawing some current, and it quickly goes up. Without the series resistor, I end up at 5 volts already at 220 milliamps. This thing's drawing pretty much what it needs to be on. I probably only have to take that up maybe a volt. Let's try that. Put my power supply up to 6 volts and then turn this up. Whoa, did you see that? Did you see that spike up? Turn it on, and very quickly it spikes up, because obviously I'm dumping much more into this than it can handle. It's going to draw as much as it can, which is a lot more than I really want it to. So it's probably doing damage to this already. So just from 5 volts to 6 volts without any series resistor, I could probably toast this darn thing. So tell you what, let's put a just a resistor in there. Let's put the resistor in there and see what happens. So here we go. I've just connected up the resistor that was in series with this LED, so I'm just going to be using that as my circuit. So this is not there really. At 5 volts, reference voltage, and that's a bit lower, so this is drawing that voltage down slightly. Current, I've already got some current in there, even at 1.25, 70 milliamps I think that is, because I'm on the 5 amp range. Start turning it up, quickly goes up, 3.1617 volts. Can't get any higher than that because I've only got 5 volts on the power supply. 200 milliamps. So let's turn that down. Turn up the voltage to, let's do that, 9 volts. So now I've got 9 volts. That hasn't changed really, neither has the current. Start turning that up. But this time you can see I'm getting a lot more current coming through. I can actually see how much current is coming through there. 450 milliamps on a 150 ohm resistor. 7 volts. I've got 9 volts on there, so we've got about 2 volts drop out with this resistor. Let's turn that down and crank this up to 14 volts, which is maximum for this power supply. Again, these two haven't really changed. Voltage hasn't changed, current hasn't changed, so let's crank this up and see what I get out of it. Look at that, I get in 11.66 volts and 740 milliamps across this. That's getting warm. I know it's getting warm because I can smell it. So yeah, so you can see that can draw quite a lot of power, quite a lot of current through there, and it's going to be dissipating a lot of power. So brilliant. So yeah, we can get quite high voltages if we want. So let's move over and have a look at this second one. Actually, I'm going to try in here this 1K resistor rather than this 4K7. So let's change that over. Okay, so I've changed out the pot and now got the 1K pot in here rather than the 4K7 that I had in here before. And let's see what this gives us on the output. I've got 5 volts to start off with, which is, with this big resistor, it's going to be 1.26, 70 milliamps. Let's turn this up. As it curves up. All the way, that's all the way up. Still got lots of turn on the pot, but I'm only getting just over 3 volts with 200 milliamps. Let's turn that back down. Want the power supply up to the 9 volts. Turn that up, and this time I'm getting 5.8 volts out of it, but I'm getting 370 milliamps now, a lot more through this resistor. And then all the way up, 14 volts on the input, 1.223 on there, 70 milliamps on the current. Let's turn this pot up, and I get out 5.8 volts and 370 milliamps. So with the 4K7 I could get all the way up to like over 10 volts on here, but this pot, the 1K pot, obviously restricts the amount of adjustment I have on the 317, and so I can only get 5.8 volts. I think I calculated it to 6 volts, was it? Something like that, about 6 volts as a maximum from this power supply, and that's about right. So yeah, the smaller the value of the pot, the lower your adjustment from the reference voltage will be. Obviously, if you want to put more voltage into it, let's say you're going to use 30 or 35 volt, then you'll need a bigger pot to be able to have the full range. So instead of this 4K7, you could use a 10K, and it's quite easy enough to calculate what your range is then going to be for that pot. Brilliant. But I suppose another thing we've got, which I'm going to move on to now, is this little setup here, which is actually going to have a resistor that limits the current. So effectively what I'm doing is going to put resistor in the series with the 317, so I'm going to have a certain amount of current, and as I've said, to calculate that current is the voltage reference over the R1, and I've got, I think I've got, is it 1, 0, 0, 3 10 ohm resistors in parallel, so I've got about what, 3.3 ohms, is it, something like that. So you know, certain amount of current limit in there. That's what I've got, something like that, except I'll need to get and put my 4K7 back in the circuit, so I'll get that set up. Okay, so now I've set up the other LM317 with the current limiting resistors in there. Connected up my LED again this time. I've got 5 volts, so let's turn it on. Just cover that over. I know probably won't be that bright to start off with, and 5 volts, 1.22. There's no current there at all. I have got it with the resistor in series, so see how that has an effect on it. Turning on, I've got 3.2 volts, and there's nothing more to be got out of it. About 20 milliamps, which you can see actually it's not particularly bright. It's bright enough, but it's not overpowering, because it's just not drawing anything like the current it would be wanting. So let's turn this up, go to 9 volts, let's turn it up, keep going. We've got more voltage this time, and I know this LED is rated to, supposed to be like 3.3 volts, 1 watt with about 300 milliamps, but even at the 4.8 volts, and this has got 9 volts going into it, so we're not getting anywhere near what I would expect. You know, you'd expect sort of a couple of volts drop, so more like 7 volts out here. I'm only getting 120 milliamps. Turn that down. Whack this all the way up to 14 volts. Start turning up. And we're still only getting about 4.8 volts and 120 milliamps. This is now limiting what I'm going to get out of it. So even with 14 volts off the power supply, it's being restricted quite heavily, really. So let's turn that down. Tell you what, let's connect the LED without the resistor in series. So put that there and turn this on. 1.22 volts to start off with. Turn this up. I would expect to get more current now, because we're not using this resistor in series for this LED. And on 5 volts, we're getting about the same thing, really. 2.8 volts, 60 milliamps. Not overly bright. Let's turn that down. Up to 9 volts on the power supply. When it comes, and look at that, the voltage still hasn't gone up. 2.98, just under 3 volts, 130 milliamps. Let's see that out flight. 140 milliamps. So not having any problems there. Wax all the way up to 14 volts. We go on the voltage on the pot, 2.9. Just again, hardly any change. So what I've got here is something's a bit washy. You can see it flickering a bit there. 140 milliamps, about 3 volts. It's I think it's going to give me any more than that, even though I've got 14 volts on the power supply. So yeah, if you put a resistor in there to limit the current, it will have a big effect on whatever you're going to be powering. And of course, you could set your resistors so you have a very specific voltage out, or you can use a separate one. You could use one 317 for the current limiting, so like with this here scenario, and then use your voltage divider set with your pot without that. So if you didn't have that and just had that as a second stage, you'd have one current limiting and then the second one for voltage regulation to decide what you want to get out of it. There you go. LM317. Quite a versatile little device. I really do like it. So I've had quite a bit of fun messing about with the LM317. It's a nice little device, great for low voltages, anything between sort of 1.5 volts all the way up to 30, 35 volts, something like that. So get hold of a few, have a mess around. I'm sure they'll be great for a project. I did notice on the data sheets though that there are quite a few other circuits, test circuits, and other types of uses for the LM317. So actually, I might investigate some of them and see what I can do. Anyway, if you like this video, give us a thumbs up, subscribe, and all comments will be welcome. See you next time.